want to say a very big thank you to everyone that has been following my page and those people that are live following me right now. And I also want to implore everyone to please kindly like my page. Beyond watching the video, at least a kudos, thumb up, like it, and like the video, like my page. Today I'll be talking on control blasting under the subtopic of maximum budding. What is a budding? Budding is the distance between two rows of hole, or the effective distance between the first row to the free face. So budding is one of the blasting parameter that is used in controlling blasting and controlling the effectiveness of the energy released by explosive at detonation. So the work control blacks, as I've explained in my previous video, is not limited to blasting carried out in close, like the construction companies trying to construct road in a close, in a place close to community or close to company. Thereby, they need to blast a rock, an intrusive rock, or an in situ rocks that is blocking the topography of the road. So it's not limited to that though, and it's to extend to that. So the work control blast is also applicable in blasting for mine, in blasting underground and surface. So the work control is also extend to the control of energy released by explosive placed in ore for the production of crudes for the production of crude. So blast control in this extent of a maximum budding, I will try to explain some of the effects of a maximum budding, that is excess budding, on the control of explosive energy, the impact, and some of the advantage also, and the side effects on the production of blasting. So control blasting, as I've said earlier, is just the control of energy released by explosive to achieve maximum production at less impact on the environment and on mine workers and equipment. Though it's obvious that blasting is one of the operations that is very dangerous and can lead to the damage and destruction of a lot of things if the energy release per time is not well controlled and quantified in such a way as to perform the work and not perform the work in an excessive way that will lead to the destruction and damage of buildings, damage of free face, damage of mine wall, damage of supporting structures. So in this case, as I've defined budding earlier as a space between two adjacent rows, adjacent drill holes, and also technically is defined as the distance, the effective distance between the center of the drill hole of the first row to the free face. So at detonation, the blasting tends to occur within the rows by what is termed budding movement. This budding movement is highly applicable when detonation occurs. So as I've explained in some of my video earlier, that blasting tends to fragment and break rocks under three different ways. One, under compression; one, second, under shearing; and third, under tension. So the first one, which is under compression, tends to fragment the rock at this condition whereby the release energy is greater than the compressive strength of the rock. So that type of breakage, that type of fragmentation occurs at a close radii. So at initial, the explosive energy released as the CG plane is higher. So the compressive strength of the energy released at that time is higher than the compressive strength of the rocks. So that tends to crush the rock within the hole. So, and also the shearing, that tends to occur when, as a result of the heterogeneous and the anisotropic condition of the rock that is being fragmented. So due to that, there tends to be a dislocation between two rock particles, rock grains, rock minerals that is receiving the same quantity of energy at the same time. So the strength of each mineral grain tends to vary due to their heterogeneous condition. As we all know, mineral is composed of different elements and rock is composed of different minerals, like the way the response
Okay, I'll be handing the video here, then we'll continue on the next video.